Hi. So in this video, we are going to see why we are going for the multi-level paging. So before this video, I have uploaded one on video on this topic. So if you haven't watched it, please watch it because we are going to use these concepts while we are solving the questions later. So please watch it in a sequential manner in order to understand all the concepts. So let's start with what is the need that we are going for a multi-level paging. So I have taken this context from the Galvin book and let's see what it is saying. So in this, we are given that we have a 32-bit address space that I have already drawn here. As you can see, this is a 32-bit address space I am drawing, and it has 4 KB of page sizes. Okay, so 4 KB pages means I have drawn this physical memory, and I am assuming that each is pointing to 1 byte only. This is only 1 byte of each entry, and if I divide this as 4 kilobytes, which means that 4 KB is actually 2 power 12 bytes, and since each entry is considering 1 byte, so I can consider that this is actually 2 power 12 entries. So if I group 2 power 12 entries here, so how many such groups will be created? Which is equal to 2 power, obviously you can divide this, that is 2 power 22 is my total number of entries, and we are grouping 2 power 12 into one entry. It comes out to be 2 power 20, and for addressing this 2 power 20 we just need 20 bits, and that is the number of the pages. So number of the chunks in this level, that is, these are the chunks that are formed. These chunks will be obviously 2 power 20 as we have calculated. So now let's see what we store in a page table. I hope you have learned paging concepts because without paging you can't understand this. So I'm directly jumping into calculation of the size of the page table. So if I calculate the size of the page table, you can see it will be the number of the pages into the page table entry size. Generally, the page table entry size will be given in the question, or you can assume it as the frame number and also the control bits. So in this question, it is given that we are having a 4 bytes of the page table entry size. It is a PTE, which is a 4 bytes, obviously. So it is given in this question, and 4 bytes multiplied by 2 power 20 bytes. 2 power 20, sorry, not bytes. 2 power 20, because these are the number of the pages that you have, and these many will give me 2 power 2 2 bytes. You can calculate it also from here, that is 4 megabytes. Okay, so 4 MB is the size of this page table that I have to maintain, and this is a flat level page table. Okay, so what is the difference between a flat level page table and for a multi-level page table? We know that for running a particular process or only a single page of it, we need the information about what the page is using and where the page is stored. So for that, we need to store the entire page table in the main memory. And let us consider that we are using only one page of the process. Now, what is the size of this one page? This has 2 power 12 entries, okay, and each entry is of size. This is the number of entries that I've calculated, and each entry is of size 1 byte. So this is 2 power 12 bytes, which means it is just of 4 kilobytes. Okay, now if I calculate the size of the main of the page table from the previous calculation, it was giving me 4 MB, right? So for maintaining a 4 KB page table inside physical memory, I need to maintain its overhead for 4 MBs, which is obviously quite not feasible and makes no sense because most of these entries will be invalid for me because I am using only one page and it will be pointing somewhat here or here or here or anywhere. But it will be only one cell which will be pointing to this page, okay, which is the frame number. It will be pointing to this frame number. Just I require only one cell. But what is the need of keeping this entire table in the main memory? There is no point in doing this. So what is the savior in this case? The savior is the multi-level pages. Okay, in multi-level pages, what we do is to divide this entire pages, that is a page table, into several chunks. Now, as you can see, I have mentioned the word chunk, not a page. Okay, so in many questions you will see of gate also that they are dividing it as per the pages. So that is used for simplification of the problem and not The actual concept. The actual concept is you can divide this into any parts. Like if I divide this is having 2 power 20 entries. So if I divide this into 2 power 10 into 1 and the rest 2 power 10 into another. So we will just having the two parts, which they have done in this case. Okay, that 2 power 10 into this and 2 power 10 into that. So yeah, that is also possible. But I'm saying that this address split must be given in the question. Okay, you cannot assume any address split by your own. So having given this address splits, we can see that there are separations of the address spaces, and we just need to keep either of them because we just need one entry and just one entry from this one or from this one. So either of them can be kept in the main memory. But what is wrong with the previous concept? The previous concept says that just we need to fit into the page table, and that is why we are doing multi-level paging. But that is not correct. Why? Why it is not correct? Because the page table has no indexes in it, right? It is used from the indexes from the as like the offset bits. Like for the 0th entry, it corresponds to the 0th page, and the last entry will correspond to the last page that of the process. So if I divide the page table, there will be I will be losing the information that which page table was after which one. So for that purpose, I just need to keep a pointer that is which page table is after which one. That is why there is a need for the multi-level paging, and this is how the multi-level paging concept works. That is not obviously based on that concept that we need to fit the page into some page table, and that's how it is working like that. And most of the teachers and aspirants will think like that only, but it is not actually that way. So I have taken these two contexts from Galvin, and this is I think from the Stallings book. You can read it, and obviously I have attached a few pros and cons regarding this topic. So in the next video, we will be solving, I guess, the first question on multi-level paging, and let's see you in the next video. Thank you.